Hi everybody. I remember my first meet with Alina Dolgikh many years ago. After my talk about functional programming in software and especially in data engineering, I don't remember, it was maybe 4 or 5 years ago, and it was the first time I heard about this conference here. So I'm so excited to be here right now, and I'm very happy to talk something about functional programming here. Let's start. It's my talk is called Kotlin DSL for LaTeX, or LaTeX DSL for Kotlin. Both titles are correct from syntax point of view. So let's start. I'd like to say a few words about me right now. So I spent many years, 15 or 16 years in academia, and I taught many computer science courses, including functional programming, partial evaluation, and so on. After that, I joined to data science and data engineering team in a classic social network. Nowadays, I'm a team leader in quite new JetBrains project called Big Data Tools. Big Data Tools is a plugin for IntelliJ. Right now, IntelliJ Ultimate to support many big data software like Apache Spark and Apache Hadoop. But today, my talk is nothing about big data or anything I'm working for JetBrains. It's kind of my hobby project, and I started recently. So I'm very happy to present my effort here. So how many of you have some Kotlin experience? Not so many, but it's okay. Scala experience, I know that. Okay. Do you know about TeX or LaTeX?
Yes.
Yes. It's amazing, because I don't want to talk about implementation details of modern typesetting software. So, TeX is a pretty amazing piece of software which makes papers, books really beautiful, especially if you are heavily using math notation in your documents. TeX was designed and written by almost mortal Don Knuth, the father of modern computer science. But in my talk, I will refer to particular implementation of the TeX system called LaTeX, which was created by Leslie Lamport. So before I'll talk to you about why I decided to make such weird stuff in Kotlin, let's talk about usability issues in LaTeX. So this is a very good example. Let's consider if you want to use footnotes. It works fine if you are working on paper or book or something like that, but if you are going to use footnotes, for example, in Beamer, it's necessary to change usage of the footnote tag in LaTeX. So it's not very useful, really, if you are going to migrate some piece of your tag document from one medium to another, for example, from article to Beamer, is pretty difficult, and you will have a lot of errors, and your document wouldn't compile in LaTeX. So my personal motivation was pretty simple. Right now, I need to create many presentations with graphics, formulas, and code stuff for my next course about partial evaluation. So I decided to change anything and maybe be more productive. But from other point of view, LaTeX is industry standard, so I don't have any intentions to replace it or do something like that. But if I have to use a Turing complete language to create a presentation, I'd like to use something more familiar. So I decided to create an embedded domain-specific language which is compiled to LaTeX. Let's start. What is Kotlin? Kotlin is a multi-paradigm, statically typed general-purpose programming language. It's been developed mostly by JetBrains. Personally, I'm not engaged in Kotlin development in JetBrains, but I have a couple of commits in some parts related to scripting and interactive interpreter. So, how about extension functions? Many of us are not familiar with Kotlin, so I like to try show you Kotlin's the most useful features related to domain-specific languages. It's really amazing feature, allow us to bring new functionality to existing classes. So that's in this case you can see capitalized method, extension method, which is attached to string class. So this is implementation exactly from Kotlin standard library. So it's pretty easy to attach new functionality to existing Java library class, for example. The second thing that I'd like to mention here is Lambdas. Lambdas are first-class citizens of Kotlin, but the most interesting part is how Lambdas implemented in the syntactic layer. For example, you can use curly braces and split arguments if you have a function with more than one formal parameters. Here the second one is lambda, so that we can split it and use curly braces separately. The bread and butter of the embedded DSLs in Kotlin are type-safe builders. Do you know something about type-safe builders? Oh, not too many. Let's start. So that let's start from very simple example. It's text DSL is the really comprehensive one, but we can start from something really small and tractable right now. So let's start from classical one. It's suppose we would like to create HTML-like DSL in Kotlin. So that let's look at this really weird piece of code. So you can see extension lambda attached to HTML object here. So this object is called a receiver object. The main point is that this object is accessible from this lambda via this keyword. I mean, you can write this dot. So moreover, we will see it in the next slides. You really can access to all members, all accessible members of the receiver object without using this itself. So it's a really useful feature which allows us to create very powerful DSLs in Kotlin. Let's go forward, and if we are going to create something like HTML, we need more text, and so we need to have some more general comparing with the last slide. So we would like to generalize initialization method in a tag here. So after that, we can create some parts of DSL just by creating two functions. One function in the top level called HTML, and the second one in the scope of HTML, which is called head. So we just can reuse our init tag functions here, and so will be very easy to add new tags in our DSL. Is it okay? Great. Now we are ready to create a very small program in our DSL here, so we can write something like that: HTML, curly brace, head, curly brace, and so on. So that's head is accessible here because head is attached to HTML object, so and it also accessible via receiver object, but we don't want to write this dot head here, so just skip it. Now it's easy to extend our DSL with new tag, for example, just edit something new. But the problem is that this piece of DSL code will be absolutely correct right now, so we can use head and head, but we would like to avoid it, so that's but Kotlin language is smart enough to manage that, so we can use annotation here to restrict calls from outer scope. This annotation is called DSL Marker, so if you want to carefully manage your scope, you need to create some annotations derived from DSL Marker and use it everywhere in your code, and mark by this annotation any existing tag. For example, right now, because every our tag is inherited from class tag, so we need to mark only one class here, a parent class, so that it will work okay for this example, and this code will be syntactically and semantically incorrect for Kotlin compiler right now. So that's Kotlin tooling who will restrict you to use some weird code in your programs. So let's go to LaTeX implementation. This will be a little bit difficult, and there will be a lot of Kotlin code here, but I will try to explain and I will do my best to make it really accessible to you. So let's start from a very small overview. There are some topics I would like to cover here. So the document structure, how to extend our DSL. I mean, I can't implement a whole set of features of LaTeX language, so I need to provide a kind of API to extend our DSL. And I'd like, of course, support external packages. And very interesting issues, it's really funny, is related to unit set length. So you can implement unit set length very easily in Kotlin right now. But the bad news is that mathematical notation is a really subtle example and cannot be handled easily by Kotlin right now, but it's a really discussable issue. So general remarks. LaTeX is really huge, so I'd like to implement very, very small part right now. And I'd like to leverage Kotlin features to reduce user pain points. And I'd like to consider and discuss here some Kotlin limits related to DSL buildings. What's about document structure? Because almost all of you are familiar with LaTeX, so everyone can imagine the result of such kind of DSL in terms of LaTeX code. So I think that it's easy to think about this like a compilation from one language to another. I mean, this piece of code will be translated to the same, semantically the same LaTeX code. So I'd like to have this kind of functionality. So document is a root element here. I think it's almost all of yours remember that there is a preamble in LaTeX, so that we will decide to handle it a bit later. But right now we don't have any preamble here, just the document. So how we can build such document structure? So let's start from tag with text. This is abstract class which can contain text, for example, section or subsection. It's pretty easy to implement. We need to have children here. Both text element and tag inherit abstract class element. But right now we are interested in text much more than text elements, because text elements are trivial examples of the element class. The main building block of our document structure is element. So this is an entity which can be rendered in our LaTeX document. And here you can see basic implementation of the general tag, I mean tag with name. So when we are going to render the tag, we need to render children tags as well. So this is pretty easy, okay? How to manage preamble? As I mentioned above, the preamble is something from start LaTeX document. It's all before tag environment, document environment. So to manage preamble in the same way, we need to outer scope, for example, but so the better way will be to do something like this. We can use the first parameter and for preamble and pass it to document itself. It will work much better because we don't need to have outer scope here. because we need only document object as a root object. So let's go further. Extensions and packages, it's a very interesting thing that I'd like to talk about this topic because it allows to understand how to access the preamble from any point of the document. For example, suppose I'd like to implement some features from any particular package, like verbatim, for example, in this way. So I'd like to have the ability to print program code in my presentation beamer. We will face with following problems. We don't want to force user to import package twice. I mean, if you are implementing a library for DSL, you have to import such package in your Kotlin code, and I don't want to import LaTeX package which related to this piece of Kotlin software. So verbatim environment itself requires beamer frames to be fragile. This is one of the biggest problems here. So that's this means that if you are trying to use verbatim tag in frames, you must change signage of the frame itself. So they need some kind of AST, I mean abstract syntax tree, and we have to navigate to root object here. So in order to add the package to preamble implicitly, we need to solve these two problems. So we need to add a parent element to any our text or text elements. It's pretty easy, and we need to add the get document extension method to find the document itself in the old document structure. So that's the second thing, that if you are going to do it stupidly, we will fail, because we need to, we will know about which particular package we need to import just after the rendering process of this particular element. So that we need to have some kind of after method in, for example, tag to catch that. So let's add the use package extension method to provide access to preamble from any tag, and after that we will be able to add use package tag from any point of our document by calling after and override after method in our class. So environment class represents here a paired tag in the form of begin and end. For example, document itself is environment, frame is environment, and so on. I hope almost all of us are familiar with it. Okay, it's pretty easy. In this particular case, we also need to manage indentation. Because verbatim code is need to be aligned properly. So it's really easy, and I like to skip it. Let's go. The main problem here is, for example, many of yours know about verb tag. I mean, verb tag in verbatim package allows us to inline code in our text. So this is a very big problem, and implementation of such functions is much trickier compared with this piece of code, but we will have problems anyway because we can't control string interpolation process in Kotlin right now. But if, for example, in Scala, you have much more control on that. A combination of, sorry for that. Combination of extension functions and class methods allow us to change semantics of verbatim in context of frames, for example. And so we can use our verbatim functions from our package and change behavior of the frames slightly here, but adding optional parameter fragile to our environment absolutely without any user intention, just automatically. So this is very good because you don't need to think about how I can handle my problems of compatibilities between my text and my document. So that we can use the same trick, for example, to handle footnote issue. It was very boring stuff about document structure, but it's much more interesting because, for example, I'd like to use some links in my document. For example, I'd like to have multi-column document or multi-column presentation. So really, I have to operate with links with units or special ones like a text width. So in Kotlin, I'd like to have something like that. So it looks reasonable because here this code has absolutely the same semantics as the first one. But it's really easy to do that in Kotlin, and it will be a very beautiful solution here. So that we need to introduce links interface with operator times, which allows us to multiply from the right to a number. I mean, double or integer or something like that. And to handle both cases mentioned above, I need to implement two separate lengths. I mean, measured one with units and special one if we are going to multiply to string, really, because from LaTeX point of view, slash text width will be kind of string. So that's it will work absolutely okay, but we need to provide some additional extension method to provide the symmetry of the operator times here. It's pretty easy. And it will be absolutely great to have units as properties, so that we can just add the properties centimeters to number class. So we after that we will be able to write something like 1.cm or 1.03.cm. It will be okay. What about mathematics? This, in some sense, it's easy to use, I mean, Greek or Latin symbols in our DSL just by defining new symbol in our Kotlin code, and we can use it at almost in the same way as we do in LaTeX. But if you are trying to use real mathematical formulas here, we will be really unhappy. There are a lot of bad news here, so operator overloading in Kotlin is not flexible enough. For example, right now, it's impossible to overload less than and greater than to return type other than Boolean. More, the assignment operator cannot be overloaded as well, and the assignment itself is not an expression, so we can use assigning our expressions in the same way as we do it in LaTeX. You can't introduce new operators in the way you can do it in Haskell, like this one, for example. Moreover, brackets and braces really cause a lot of problems because the main problem is the first one. So if you don't need to have the first bracket or brace, it's manageable because you can use apply and get. Apply and get is a very special operator like functions, which allows to use to access an array style or constructor style. I mean, just use square brackets and braces in your code with special meaning. So, summary. We have only 2-3 minutes. So, Kotlin really has powerful capabilities to create DSL, and proof of concept of LaTeX-like DSL has been developed, but it's impossible to restrict DSL to generate always valid LaTeX. It's a very important thing. That's because if right now it's impossible to manage all stuff without using strings. But if you are going to use strings, we have to use standard interpolation rules. So we can't guarantee to provide valid LaTeX generated code. So I can't understand right now how to create effective and useful DSL for math, but I believe that the most promising application of such DSL is comprehensive graphics packages, or maybe tables and other very difficult to use concepts in LaTeX itself. So I have some kind of roadmap, and I'd like to develop a new approach to work with math in the DSL in near future. I mean, maybe a couple of weeks. So I'd like to support document types, more document types and core primitives. But right now, this presentation was made by this DSL itself. So it's kind of recursion here. And I'd like to support BibTeX as well, and citation in general, and maybe support the most popular packages. I don't think it's a very big problem and really tractable. So, about links, you can contact me, feel free to contact me in Twitter, Telegram, or maybe by mail. So I will commit all my changes into this repository. So if you have some ideas, pull requests, it will be really appreciated. So thank you. Questions?